Alright, welcome back to part 2. Now we're going to write the script for this character controller. So if I jump to player right here, I'm going to make myself a script for this. So I'm going to create a folder to keep all my scripts in, and I'm going to call that scripts. And then inside there I'm just going to create a new C# script. And we're going to call this third person character controller. And while I am here, I'm going to attach it onto the player right now. Just make sure that went on okay. Remove component. Yeah, I only need it on once, so I've got the player on the third person character control. I'm just going to open this up in Visual Studio and we'll get started. So this is just loading up. What we're going to do first up is just get the character controller. So I'm going to make a type character controller and I'm going to call it CC, and then inside the start I'm going to say CC equals get component, triangle brackets, and then character controller, close the triangle brackets, and there we go. So I was having all sorts of trouble with that, and don't forget the semicolon. Here we go. So now we've got the character controller, we can do the move. Now I'm going to do it slightly differently to I did with the first person controller. So I'm going to create a vector 3 to hold our movement, and I'm going to call it direction. And then I'm just going to initialize it as I get the input. So I'm going to make a new vector 3, and I'm just going to make the x-axis equal to input dot get axis, and then pass in horizontal, making sure that's spelled correctly, then a 0 for the y, and then just directly take the input dot get axis again and choose vertical for that. So what we do is get the input horizontal for x, vertical for the z, and as we initialize this direction vector, we're just going to get those inputs. So it's a nice one-line way of doing it. Now I'm just going to also clamp the magnitude of this direction vector, so we can't move in a faster direction diagonally than we can any other direction. So I'll just do this one and explain it as I go. So the direction equals to vector 3 dot clamp magnitude, and we just pass to that function the vector and then the maximum length. So because we're going to be this is just raw input right now, I've not multiplied it by anything, it's going to be between -1 and 1, so the maximum magnitude we want is 1, so that it doesn't go faster horizontal and vertical. So that's more or less it. Now we should be able to say cc.move and move in any direction. We obviously want to move in the direction that we've taken from input, but it'd be a good idea now to get some speed as well, so and also to make it frame independent. So I'm just going to make a public variable up here. I'm going to call it speed. I'm going to make it equal to 5 by default. Public float speed. Now that way, when we get this, when we do the cc.move, we're going to multiply that by speed, and we're going to multiply that by the time.delta time, so that we make it frame rate independent. So looking at that code, it's fairly simple right now, and it should pretty much work okay. So I'm going to save it, jump back into Unity and hit play, and what we should see is that the character is moving around, and if you press the directions diagonals, it'll also not speed up anymore, it'll still go at the same velocity. So that's basically the first part. The next part is one of those weird things. What we want it to do is we want to make it rotate to the direction that it's going. And it sounds like a really simple thing to do, but it ends up being quite complicated because it's all of the quaternions. So the basic line that we need is that we want to set the transform.rotation to be equal to a quaternion, a rotation that we calculate based on we lerp from one rotation to the next, so we smoothly move. So we say quaternion dot slurp, and then we take the current transform dot rotation, and we want the where we're going to go to. So we want to actually get the direction, but we want to get that as a quaternion, so we say quaternion dot look rotation, and then we pass the direction in. So that will say that we're going to go from the current one, the current rotation, to this rotation, and we're going to say by how much. And what we're going to do is I'm just going to make a hard-coded value of 25 just now, times time.delta time. You can tweak that value as much as you like, just to try and get this right. But let's not look, transform to rotation. Oh yeah, put a minus instead of an equal, so that's why I was not doing it. So this quaternion dot slurp will just smoothly go from take the current rotation from the current rotation to the direction that we're going in. One issue that I found when I was testing this is that we don't want to do this all the time. This direction vector isn't guaranteed to be normalized. So what we can do to make life easier is just make sure that we're only doing this when we're moving. And the way you can do that is we can just say if. So I double tap tab. I'm going to say if the direction is actually the direction dot magnitude, so the size of that vector is greater than 0.01, so we know we're moving. Then we're going to take this line and copy and paste it into here. So this is going to just say that if we're moving, then make the current rotation slurp towards the direction. So running this again, if we jump to Unity just to check that it's working, what you should see is as you press play, when you move the character, you should see that he turns, and this is why we put the sunglasses on him, so that he looks really cool. And he does move quite fast, but it's entirely up to you how fast that rotation is, because you can change it in the code. So that's more or less the next bit. What we're going to do now is make it so that the camera rotation is the direction that you move in. So in order to do that, we're going to need a handle to the camera. So I'm just going to make a public transform up the top that's going to hold the camera. So public transform, I'm just going to call this cam. And while I remember, so I don't forget, I'm going to jump back to Unity with this compiled. Click on player, and you'll see that that slot is there. So we're going to drag main camera onto it. If we there's a couple of ways we can do this, and what I might do is just do this as a function. So what we're going to return, we're going to make a function that returns a quaternion, just because I want to teach you guys how to use functions that return something rather than just void functions. So we're going to get a function that returns a quaternion. We're going to call it get cam rotation. We're not going to take any parameters because we know the camera already. The red line is here because it needs to return the quaternion, so it will go away once we get this up and running. I'm going to explain as I go as well. So I'm going to create a vector3 that is going to hold the camera forward. I'm going to call this cam forward, and I'm going to make that equal to camera.forward. The reason I'm doing this is because if you do it, the camera can be tipped up or down, and you don't want the character controller to be moving up or down. You want it to be moving flat. So I'm going to get this cam forward, and I'm going to zero out the Y value, and then just normalize it again so that it's a normal, a 1 unit long vector. So we've got the cam forward, and then I'm just going to say cam forward dot y equals 0, so that will zero out the Y, and then I'm just going to say cam forward dot normalize, and that'll just turn it back into a single unit vector, so we can use it to rotate things. Now to turn this into an actual rotation, we want to make it and get a new quaternion. Do I need to? No, I don't need to do that. I'll just return it. So I'm going to return quaternion dot. We did this trick before. We used look rotation, and we passed this cam forward. So that will return this quaternion that's generated from the look rotation of this forward direction. So we've got this function now. Now we need to actually use it, and this is where the clever stuff comes in. So I think we'll do it just after the direction here. So in order to work out what the direction is once it's been rotated by a quaternion, it's actually quite cool. You just multiply the vector by the quaternion. So if I say direction equals, and we get we want the camera rotation, so we're going to say get cam rotation, and that will return a vector, return a quaternion, and we're going to multiply that quaternion by direction. I could, if I wanted to, create a quaternion here, like a local quaternion, and then call this function. But I think it's more efficient to just do it here rather than have to create a local and then use the local on the very next line. I'm just going to do that just like this. So we're going to test this to make sure it works. If we just go back to our code again and we hit play, you might ask, how are we going to test if this works? Because everything's the same. My camera, however, if I click over here, the camera, if I change the rotation of the camera, so I'm going to change the Y rotation, so rotate it round, you'll see as we move the player, it moves relative now to my camera. So it doesn't matter what rotation the camera is on, the player will move relative to the camera's rotation, which is exactly what we want. So that's the character controller. In the next video we're going to make the camera orbit around this this player. Hope you're enjoying the series, and continue on to the next one.